Dr. Z. How you guys doing? This is your host, Trent Thomas. This is another episode, Are You Smarter Than Dr. Z? Today's topic will be action potential and muscle contractions, and these are our contestants. Contestant 1.
I'm Lindsay Camrick.
Contestant 2.
I'm Lucas Malagues.
And contestant 3.
I'm Dana Bray.
This is round 1. The category is going to be action potential. Every point is going to be worth 10 points. Are my contestants ready? All right, lights, camera, action potential. Question 1. What is the resting membrane potential of the cell? Also describe the first step of action potential and what ions are involved.
The resting membrane potential is negative 70 millivolts. First, a slight depolarization occurs where sodium channels open slightly and depolarize the axon membrane to its threshold.
Question 2. What must the action potential reach in order to happen? What happens when that's reached?
The threshold. Once it's reached, sodium channels are wide open and sodium ions rush into the cells and depolarize the membrane even further.
Question 3. Once depolarization occurs, which ion comes into play and opens voltage-gated sodium ion channels, and what happens at the peak of an action potential?
The answer is potassium. Potassium channels begin to open as the charge approaches its peak, which is a positive charge, and then it flows out of the cell down the axon and opens the voltage-gated sodium channels at the next point.
Question 4. What happens during repolarization?
So the membrane is depolarized, so voltage-gated potassium channels open. Potassium ions flow out of the axon, returning the membrane towards its original depolarization. And once this occurs, the voltage-gated potassium channels close. This is known as repolarization.
Question 5. What can occur after the cell is repolarized?
Hyperpolarization. The cell becomes hyperpolarized and overshoots resting potential, but is ready to fire again at minus 7 millivolts.
That is the end of round 1. Round 2 will be muscle contractions. Question 1. A muscle contraction is initiated from the electrical signal. This signal is sent from the motor neuron in the CNS to the muscle fiber. What is another name for this electrical signal, and how does it go from the neuron to the muscle?
An action potential. The space between the motor neuron and sarcolemma of a muscle fiber is known as the synapse, and these electrical impulses or action potentials are sent across the synapse. Question
2. What is released from the neural signal that initiates an action potential in the sarcolemma?
Acetylcholine.
Question 3. This ion plays an important role in the muscle contraction. It is first introduced when the action potential spreads through the muscle fibers and causes the release of it to the sarcoplasm from the SR.
Calcium.
Question 4. Once in the sarcoplasm, what is one of the first steps the calcium takes a part in order to help begin the muscle contraction?
Calcium binds to the subunit troponin on the thin filaments actin.
Question 5. The act of binding causes the movement of what subunit, exposing what?
Tropomyosin. Removing this exposes the active sites that lie on the actin strands.
Question 6. What creates a cross bridge?
Myosin heads begin to bind to the exposed activity sites, creating a cross bridge. They do so by hydrolyzation of ATP into ADP and an inorganic phosphate.
Question 7. Subsequently, what happens after the cross bridge is formed?
The myosin heads or cross bridges pull, causing the thin filaments to slide over the thick filaments and to the center of the A band, where the Z discs get closer, and also the sarcolemma shortens.
Question 8. In order for the myosin heads to release from the active sites, what needs to take place?
ATP must bind to the myosin heads and releases them from the actin filaments.
Question 9. The whole process continues until the signal from the CNS is no longer sent. Finally, who can explain what happens after the cessation of the signal?
Once the silence stops, casein is pumped back into the sarcoplasmic reticulum, and the active sites on actin are no longer exposed. The Z lines return to their original position. This is known as relaxation.
Oh, ladies and gentlemen, that's the sound of a bonus round. This round will consist of one question, in which everyone will have to write down an answer immediately after I ask you the question. Are my contestants ready? Okay. The question is, when you don't know the answer is... All right, contestants, what is your answers?
Epinephrine.
Congratulations, contestants. You have all just won an A+ on your project. This will conclude our episode of Are You Smarter Than Dr. Z? Potential and muscle contraction. Is that it? Are my contestants ready? An action potential in the sacroilium that initiates an action potential in the sacroilium. Oh my god. Question 4. Question 7. Subsequently, what happens after the cross bridge is formed? Oh.
Hyperpolarization. The cell becomes hyperpolarized. Caralho.
All right, contestants, show your answers.